Okay, so we've got some things happening here. Here's how we're gonna wrap up, or not wrap up. Here's how we're gonna deal with chapter 3. Good. Okay, listen, please. Chapter 3 is loaded, as you can tell.
Yeah.
So what I want to do, I'm gonna do something a little bit different here. We get to a point where we gotta look at some different types of. I want to look at some different types of work from you. And this is the chapter where we make a little bit of a transition. Things will still look pretty similar, but there's gonna be some additional types of like a test you're gonna do. What I want to do is I'm going to go ahead and everything up through 3.5 will be covered under 1 or 2 relatively short Math Excel tests. Okay, just normal stuff. 3.6 is kind of a cumulative, bring everything together from 3.1 through 3.5. Doesn't add really anything new. It's not for you guys. I've been talking about my tables for a while, and that's really what they try to do in 3.6. Sorry. 3.6, not a health teacher. 3.6 is implement some kind of a visual model. The one in the book, ours is better, so you don't really need to use the book for that. To use their method of illustrating in a table all the stuff we're doing. Just do it the way that we've been doing it as a group. But there's some problems in there that I want you to do. And so I've just made an assignment, 12 problems.
Can you just email it to us too?
It just, email to you. It shows up, it's kind of a weird one. Math Excel is not great. I mean, it's one of the things it doesn't do a very good job of is it doesn't allow me to put stuff on the site very easily that's not a Math Excel assignment. But being as that's where you go most of the time, because almost all your assignments are there, what I did instead was I just posted a message at the top of the Math Excel site which has this assignment, the 3.6 assignment. It's on pages 202 to 204. It's got 12 problems. They're pretty representative of I didn't make them super hard, but they're hard enough. All the different types of stuff that I think you should be able to deal with at this point in terms of finding first and second derivatives, applying the first and second derivative test with a table, and then ultimately doing a little sketch of the curve. I'm going to have you do a test, which is going to be a paper and pencil test, where I'm only going to give you, I don't know, like 3 problems. Partial credit will be available, but I'm going to have you, what I'm looking for on this test, which is, it's still a few days away, you got some time to work through this assignment, is I want to see you building a table. I want to see you showing the work, doing it just like I do it on the board, and like hopefully you're doing it in your notebooks. Right, where you're going to be writing down the function, differentiating, finding first and second derivative critical numbers, populating the table with all of the stuff that you need, and that table really tells a story, doesn't it? You can see that each row has a significance, and then based on the table, you could either answer some questions about where the function's increasing, decreasing, et cetera, or sketch the curve. And in some cases, I might just have you sketch the curve. Okay? Sketch the curve means, not graph the curve on your calculator. It means just sketch it based on the stuff in your table. Remember, a sketch does not need to be super accurate. All a sketch needs to do is just describe the general behavior of the function and anchor just a few points. Really, we'll talk about this as we go through some examples, but really we're just going to anchor our sketch to the XY axis in a couple important spots, like relative extrema, points of inflection. We could throw in zeros of a function if it's convenient, just to get a few points that we know the function's going to stick to, But really, it's not intended to be exact, right? Does that make sense? Okay. So let's look at some examples here that I think are good examples, that are ones that are going to be, I think, useful to you guys in doing this assignment. I'm going to pick some that are very similar to.
Wait, so when's the paper pencil assignment due?
Let's say, I kind of want to get through it. So let's say by Thursday. Okay. So that'd be, what is it, Monday, Tuesday? So that's going to give you about 3 or 4 problems a day to get through it in that time. Okay, which I think you can do. Let's look at one of the ones that you have to do is number 7. So let's look at one similar to that. Let's look at like number 9. Or something like number 9. I'll just probably make these up.
You could just do number 9.
I could.
Yeah.
I could. It's not on the assignment, but it's similar to one on the
start
assignment.
the timer.
No, I'm not going to do that. let's just go.
Mr. Oya,
Yep.
have you been
I'm doing
recording
that grant.
lately? I haven't been asking.
You have, no, I have been. I haven't put them up though. I've been lazy about that.
That's okay.
Today I gotta put them up though. I need to do
I'm
that.
just checking to make sure.
No, I have been recording, but I haven't done a very good job of putting them up onto the YouTube channel, but I'll do that.
Unacceptable.
Would this be on the test
Unacceptable.
or no?
This will be on, yeah, stuff like this will be on the paper and pencil test. But this is also a great way to review for the other easier Math Excel tests, because the stuff that I'm gonna be asking much more specific questions, like what are find the relative extrema, or where are the, stuff like that. Where are the points of inflection? What's the limit as x approaches infinity of this rational function? Stuff that's more geared towards, 3.1 through 3.5 kind of stuff on that one.
When did you say this test will take place?
Well, we need to get, you guys, let's talk about that real quick. So we need to get in, let's just say by next Tuesday, I'd like to have 3.1 through 3.6 behind us and moving on to new stuff. Okay?
Okay.
So you can pick, you guys think about it.
We have a review assignment before with like everything.
This is what
Well,
this
that's
is.
kind of what this is. This is a good review assignment, yeah.
So-
that-
Could we just do it on, like, if the assignment's due Thursday, could we just have this on Friday?
Sure,
So we don't have to wait a weekend to like.
okay.
get it?
Okay, so you
Yeah.
wanna do, how about this then? How about let's say Thursday, let's do the 3.1 to 3.5 shorter test, does that sound good? The online one, okay, on Thursday. And then how about like next Tuesday, we'll do paper pencil on
Okay,
this
on
one.
Monday, can we spend a
And I think that's, honestly, I feel like I'm maybe putting it out there too far in advance,
Sounds good, actually.
but I guess I'd be willing to do that, if you,
Thursday, Friday.
Yeah, that's all.
Next week?
No.
Well,
Well,
the thing is,
Oh,
are we gonna
I
go
was
through the
like-
paper pencil assignment? Cause if so, that's Thursday.
why don't we go through it on Friday?
Okay, so then when will
Why
we
don't we
take
do
the
it
test?
Thursday?
I feel like
I was getting complicated. Let's go ahead and say, let's
Go
go
ahead and
ahead
write
and
it
just, I don't wanna do it on Monday, 'cause it's a short day, let's just say next Tuesday we'll do the paper and pencil test. That'll give you plenty of time, okay? And if it turns out that everybody's done with everything, then I can always start talking about optimization, just get used to it a little bit, but
Can we review on Monday then? for
Yeah.
Tuesday?
we'll review Monday. Sound good?
Is this class gonna get easier then? Is this our hardest chapter?
I'd say this is, it's kind of a hardship. This is the end of differentiation. And so we're doing kind of the harder stuff in differentiation. Next step is we'd move on to integration, but we kind of start at the beginning, so it does build up a little bit, yeah. So the chapter 4, so
What about
harder.
Antiderivative?
Antiderivatives, that's what chapter 4 is.
Oh.
really?
Oh,
Yeah.
you've been waiting for this.
I am.
Yeah.
Mentioned it like the first day.
Okay, so here we go. So what are we gonna do with this now? We wanna build our table, right? So think about the parts of our table. We've gotta know, we're gonna take derivatives and find critical numbers and all that stuff, but before we even take derivatives, what do we always wanna do with a function?
Make it positive.
Well, we need to know, okay, remember
The domain.
domain, very good. We wanna know what the domain is, because we wanna know what the set of all the values where we'd even have to look for critical numbers would be, right? Okay, so we always ask ourselves, okay, are there any restrictions on the domain? No restrictions. So our domain, and this is a good idea, why don't you just go, let's start doing a process here. I think I very seldom have you take notes, but why don't you just go through this with me? Because this is a great template for how you should approach calculus problems. So we're gonna write down the domain, which is all reals, okay? Next step. Yeah, we're gonna differentiate, aren't we? So this is an easy one, it's a polynomial. So what's y prime gonna equal?
-1 minus 3x squared.
Okay, -1 minus 3x squared, good. Now, what are we gonna do with that?
Set it equal
Find
to 0.
zero.
Or
Okay.
find where it's undefined, but it's not.
Okay, good, we gotta find critical numbers. There's nowhere where this is undefined, right? And so in fact, I'm gonna make a few extra steps here just by way of review that you wouldn't necessarily have to put. We're gonna look for, I'm gonna indent this so we know, when I indent up here, it means that we're gonna do something with this step, but later on, we'll move straight down and take a second derivative. Does that make sense? So now we're gonna pause for a second with this step, and we're gonna find critical numbers, right? First derivative critical numbers. So where are they? It's nowhere undefined, right? It's nowhere undefined, so we get none of that type of critical number. But it might equal 0. Okay, so y prime equals 0 when what is true? Well, when that expression equals 0, right? Okay,
It's still would be
It doesn't matter.
and it does,
It doesn't.
Because it would be like square root of -1.
okay, exactly,
Yeah, X
right.
squared.
So if we set this equal to 0, and I'm just gonna write this down. If I jump this over to the other side, don't we get 3x squared equals -1? Right? And so we can, everybody see that?
Why is it,
Yeah.
it shouldn't be
Just-
negative 3x squared?
No, I'm adding it to the other side, right? And so then if I were to solve, look what I get. I get x squared equals -1/3. And so we know we're not gonna get any real zeros from that, are we?
No.
Right? Okay, so I also get, this happens nowhere, so there are no first derivative critical numbers, right?
Why does that happen though?
Because x squared, if I were to solve this, if I take a square root of both sides, I'm gonna be taking a square root of a negative number,
Oh,
right? Okay, so I'm only gonna get imaginary, so no real zeros. And really, this class is technically called calculus of a single variable, but we might as well also say for real numbers, right? Because we're not gonna do any complex analysis here, that's kind of a college thing. All right, so next step. What's our next step?
Find the second derivative.
Second derivative. Okay, and what do we get?
Negative 6x.
Okay, so we can find some critical numbers there, can't we? Or a critical number at least. So y double prime equals 0 when x equals what? 0. Because if we just set that equal to 0 and solve.
Wait, isn't that an inflection point?
Okay, so maybe, it's a possible inflection point. Remember that first derivative critical numbers are places where we might or might not have what? Maximum or minimum, right, so we're gonna get an extrema, right? Second derivative critical numbers are places where we might or might not have inflection points. Good, and then we gotta find out, we're gonna test and find out. So there's everything we need. Let's go ahead and put our table up here. All right, so. So our domain was all reals, was all reals. And we only had one thing happen at all. We only had one critical number, right? Which was 0. And that was a critical number of what derivative? Yeah, so then our 0 goes there, doesn't it? Right? That's it. Okay, so what do we have to do?
Or draw it?
No, plug in 2 numbers to the left and right of it, and it's inflection.
Okay, good. So we need to check to see what's going on. So we're gonna work as far down in the table as we can. So we'll work in the y double prime row. Move that up a little bit. And we're just gonna check some test points, like how about -1 and +1? Well, what's gonna be the sign? That's all I need, right? What is the sign of the second derivative when x is -1 or any negative number? When it's positive? Okay, so what's going on? What is that? It's an inflection point. And we could even do just a little sketch here to remind us what kind it is. If we're going from, what is positive concavity?
This might
Smiley. So that's concave up to concave down, right? And it's not necessarily a horizontal derivative though, is it? Right, does that make sense? So we know that it's just doing something like, it's going from being concave up to concave down, right? Oops, hang on, to concave down. I didn't draw that right. So something kinda like that, but not necessarily horizontal. Cause we didn't get a 0 for our first derivative.
Isn't that
Wouldn't it be the opposite?
No, that's it.
Concave.
Concave up means it's bowl-shaped up.
Oh, I see.
Remember what concave up means. That means that tangent lines sit below the curve. Concave down means that tangent lines sit above the curve, right? Yes, ma'am?
Wouldn't it have to be like that though, because there's no maximum, like relative maximum?
Well, it wouldn't have to have an inflection point because it could be something that just like, for example, what if I had just an inverse function? An inverse function just looks like this. It's always concave up. No minima, no maxima, always concave up.
What do I mean for that?
Oh, for this one, yeah. Okay, so going back to this guy then. Oops. Let's sketch this thing. Let's take our table and let's sketch this thing. While we're at it, what is the value of the function at 0?
Negative 4.
4, right? Okay, so one thing we maybe want to do is just anchor this point, right? So it has coordinates 0, 4. Now let's take this guy
How did we get 4 to send into the very first?
into the very first function. Yep, you got it. Oops. So let's do that.
There we go.
So now let's sketch this thing based on our picture, right?
Okay.
So what do we got?
0, 4.
Okay, we got a point at 0, 4, and we know that it's gonna be concave down on this side and concave up on that side, right? So then, we don't know how, I guess if we want to, we could go back and try to find,
You gotta go.
we could try to find zeros if we wanna pin this thing down a little bit more. Like if I were to set y equal to 0 and solve, that'd be kinda hard to do though, right? I mean, it's, not really. It's not really necessary, and that's not an easy one to solve, so let's not. I mean, we could do it on a calculator if we wanted to, but we don't really care about that. All we want is the general shape of this thing. So what does that have to look like? If it's gonna be concave up over here, then that means that it's doing something like that, and then it's going down right there, right? That's the basic shape. I mean, that's it.
So that's what you,
question?
Yep.
Oh, I'm sorry.
sorry. So that's like the type of thing you'd want us to draw on our test?
Yep.
Just a little thing like that?
Mm-hmm.
Sweet.
What can you tell me about, if we go back, maybe there's one other thing we could fill in that might be useful? What can you tell me about the sign of the first derivative always?
Negative.
It's negative everywhere, isn't it?
And how
Right.
do we determine that?
Because look up here, regardless of what I put in there for x squared is positive,
Okay.
times negative 3 is negative,
Okay.
plus negative 1 is just even a little bit more negative. So if we wanted to, we could even just say, we know that that's negative everywhere. And that matches our picture though, doesn't it? Because it's always decreasing. Right? You see what I'm getting at? How do I know it looks like that and it doesn't look more like, maybe it's more, I don't. I mean, that's good enough. It might be that it's much more flat than this. It might be that it's much more stretched, but that's okay. Those are specifics we don't really care about. That tells us everything we really need to know, that it's got one point of inflection at that point, and it has that basic shape. Okay? That's a sketch.
Sweet.
Yes?
So let's say we had all that, but for some reason, like we messed up, like the 4, like we plugged it in wrong, would we still get?
Oh, yeah, on the test.
Or not?
Oh, yeah, you might, I mean, honestly, on a question like that, I mean, if you made some really dumb error, but you did all the other stuff right, I mean, in some cases, I might even just say I'd get it all. I mean, because,
Yes.
not guaranteed, but I mean, what I'm saying, if I can see that you were doing the whole process. What I'm looking at is the process.
Okay.
Are we allowed to redo it?
I'll give you maybe one redo on this one.
Okay.
Are you gonna have like,
not hard ones. I'm gonna go through a couple practice ones. We'll just go through. That's what I'm gonna do now is just, during the days here, I'm just gonna go through practice stuff. So you guys,
Because it helps me so much.
let me think about it. I'll tell you about it tomorrow.
Like the derivatives of the trig functions, like for the,
Oh, that one actually.
Yeah.
is
I have it written that I use.
Okay, I'll tell you what I'll do. I'd be willing to let you use some limited, like, I'd let you make one flashcard of notes for this one. Okay, but when we come to the final, I'm probably not gonna let you do that.
We have a final.
We'll do a little final.
We said we didn't. Yeah, you promised me.
We'll see. We'll see. I'll hold it out there. We'll see. Okay, another one. Yikes. All right, another one. Okay, how about something like?
I took like a whole page just to
13 on there. Oh, here's a good one. Here's a good one.
It's not good.
That's how they start with a sword. Get to a nine.
Okay, there we go. Have a look. Next problem. Next example. This is like number, I think, 14, 15.
And the last one was like.
That's gonna go all night.
Yep.
But you said 9. It was.
Well, this one is like number 13 on your assignment. Okay.
But it's number 14.
It's actually number 15 in the book.
Can we work it out on our own?
Do you want to do a little work on it?
Yeah.
Okay.
Do I have to do exponential? I mean.
Well,
this
what's that with a
number
sword?
or no? What? Synthetic division.
No, that would only be for a rational function.
Oh.
Yeah, we'll look at one like that.
On the test, right?
What's that?
A rational function?
Oh, yeah.
On the written test?
Yeah.
I can do so much.
Questions?
Maybe. Hopefully you got something done there. At least you got your thinking organized. Let's talk about this a little bit. The derivatives are easy. I just took those. We're just polynomials. No big deal. Okay, what's the domain?
Negative.
Negative.
Infinity.
Good. All reals. So, okay, so we can add that down here. Okay, first derivative. So nowhere is the first derivative undefined. So we only are going to potentially get zeros of the first derivative as our critical numbers, right?
Yeah.
So we can trade this then for the easier equation. I could go ahead and, well, okay, I'm gonna get this equal to 0. Anything I could divide out of both sides? 4. So I'm gonna end up with, would you agree, x cubed minus 3x squared plus 4 equals 0?
Yeah.
Okay. And that would be a little harder one to, if we had a little more time, I'd show you how you could do this, but remind you, but I'm not going to. Okay. So if we use our calculator, we're gonna find what are the zeros of this, right? 2 and negative 1. Okay, there's a couple ways you could do this. You could use polysmult, which you're familiar with that, right? The other thing you could do, and this will work on any calculator, is you could go math, and then you could go up to solver, and then this is, oh, wow, it's different on here.
Wait, where's the solver? Oh.
Is that what yours does when you do it?
No.
Okay, yours just has like, okay, normally what you would do on this is you would just type in, and I guess this is what we do here too. You would just type in the equation, right?
It just asks us for
Oh.
what the number
It just says equation and then it says 0 equals.
Yeah. Okay, so I won't do it. If you've got a TI-84 plus, just use polysmult. But if you don't, real quick,
Yeah.
here's how it'll work on other calculators. You would just put in this, 0 equals, and then you would put in x cubed minus 3x squared plus 4, and then I think you have to see real quick.
Wait, how'd you get there, Mr. Oya? Math what?
That's it.
That's a
Yeah.
zero.
Try that on, does yours look like this?
Yeah.
Okay, just try it and see if it works.
I don't know, what do you?
But it says x equals point, blah, 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 blah.
Cube. And then equals, where's equals?
Dinosaur.
No, it's a bunch of name inside of the.
I should've gone the other way. Probably small.
So you gotta put it,
I will go. Where did you put it? You have to do it. It's my mom's from college. It's
Oh, you did the equal sign.
We'll try that.
Oh, yeah.
Okay, so that didn't work at all. Never mind.
Yeah.
Okay,
Good try though.
yeah, thank you. I
Does
tried.
solver not work? I was seeing if I can use it in the phone.
Oh, I thought that's what would work, but
Wait, how do you get an equal sign? That's what I'm trying to figure out.
you have to go to the test menu.
What is it?
I don't know. Anyway,
I don't remember how to why.
bad idea. So use, I don't know how to use that.
Can we just go so we know?
Yeah, let's go. So if we solve this thing using technology, and you could use Aqueduct, you could use Polysmult, you could graph the function and look for the x-intercepts for the zeros. Any of those are fine, right? We end up getting back the answers, what were they again?
2 and -1.
2 and -1. Okay, so negative, whoops, I'll make this way. So -1 and +2, and those are places where the first derivative was equal to 0, right? Everybody agree?
Yeah.
Okay, second derivative.
It was
Second derivative,
0 and 2. 0 and 2.
right. Okay, so we're gonna get back, we could factor out a 12, right, set it equal to 0 and divide both sides by 12 and get x squared minus 2x equals 0, which is x times x minus 2 equals 0, right?
Yeah.
Set the factors equal to 0, we get,
0.
shh, listen please, 0 and 2. Okay, so did everybody see what the table looks like then?
Yeah.
Because 0 and 2 are places where the second derivative equals 0, right? Okay, so this one right here is gonna be, this is weird, right? I want you to see one like this. I think we've maybe seen one of these, but we gotta look again here. One or two. When we have simultaneous zeros in the f prime and f double prime rows, it means it can be either an extremum, right? Because extrema occur at first derivative zeros or a point of inflection. And we don't know which one until we find out, but it can't be both. It's gonna be one or the other, right? So then what do we have to do here to solve all the problems? What do we need to, test points where?
On both sides of
sides.
each one.
Okay, so our test points are gonna be on both sides of each of these, right?
Yeah.
Okay, but the one on the left side of x equals 0 should definitely be where?
-1.
Right, at -1, because then we're also using the second derivative test to find out what this is, right?
Okay.
So if we go back up and look at our second derivative, and if we want to write this in factored form, which we could, this is really just 12x times x minus 2, right?
Yeah.
Okay? So now that makes, if it's factored, it makes it easier to check the signs. So at -1, what are we going to get back? I'm going to get negative times negative is positive. Everybody agree?
Yeah.
Okay, let's try, how about +1? +1, we're going to get positive times negative is negative, and then how about at 4? I'm going to get positive times positive is positive. So, what is this?
That's a minimum.
Good, that's going to be a minimum. This is going to be a point of inflection, right?
Yeah.
and that's gonna be a point of inflection. This is,
Is zero not an point of inflection?
0 is a point of
Okay.
inflection, right? This one right here, though, happens to be a point of inflection where it also has a horizontal tangent. So this one's gonna go like this, right?
Okay.
So is it an inflection?
And this
So
one's
you
just
look-
gonna go,
Yeah, it
This-
is.
this one's going from positive to negative like that.
So you plug it back to the, you don't plug anything back to the second derivative, you just plug everything back to the first.
Or,
Well, we didn't plug anything into the second derivative.
no, we did, that's what we used, second derivative.
Oh. So we don't plug anything back to the first.
No, we don't need to. Remember, the further down we can work, the
Don't
better.
worry with the derivative.
Yep.
Okay. That's what I
Yeah. We'll finish this one up first thing tomorrow, and we'll be able to plug all the signs in based on our picture.
I thought how you do these, right, to figure out how this one would look.
Hey,
How
what?
you just combine like these two, like switch them together. So like I thought it would be the opposite. Right? You go like that.
See it again?
Like this one it goes like this, right? You switch it.
Mm-hmm.
I thought like how you figure out the inflections, you just like work both of this one and this one together.
Mhm.
So it would be like, this then.
Yeah, you're right, it would be. Yeah, that one's backwards. Yeah, it'd have to be.
So this one is supposed to
Yeah,
go there.
yep, it
Wouldn't,
should
wouldn't
be.
that then be the same thing in this case?
Let's see, that one.
Because like morph them together and then you go.
Well, no, on this one it wouldn't, on this one, because, no, because it's always gonna be, see, over here, the concavity is always, so it's just gonna do, that's negative, so it's always going downhill. See what I'm saying?
So it's just like a special case.
Well, I mean, not really, you know that
Well,
if,
why like for this? Why does morphing these two together give you the right answer for this one? But then morphing these two together doesn't do that for this one.
Sure.
You want to extend that assignment tomorrow?
I don't know, honestly.
Extend
We don't
the,
have like your assignment.
Yeah.
yes, I will. Yeah, no, but see, that's wrong. That's why, because that should be negative.
Oh, I thought you guys.
No, it's negative, the concavity is
My mom asked me why.
negative,
That one's negative.
you see what I'm saying? Oh, no, concavity, no, it's positive, never mind. So positive concavity just means that it's going like this, right? Positive concavity just means, in this case, there's two possible ways you could draw that. It's either gonna look like, see, if you have positive concavity to the left of this point,
Never mind, I see it now.
you see it? Okay.
Hi.
Hey.
So I'm gonna be gone Thursday and Friday, so that kind of makes this class very complicated. So,
No, you're fine.
are we okay?
Yeah, so, I mean, I'll give you the time. It's not like-
Okay.
Yeah, you're fine. Don't sweat it. Just work hard. As long as you work hard, you'll be fine.
So if I work on that assignment,
Yep. No, don't worry.